Hello friends, we will study fractography today. First of all, brittle fracture. Let's take a brittle material, for example ceramic, and start elongating it using tensile load. In that case, we can observe that once it reaches its fracture limit, it undergoes cleavage fracture. And if you enlarge the fracture surface or see under SEM, you can observe there are faceted features. These are the faceted features. This you generally have observed in a temple where the prasad which is given that has the shape, the surface as faceted. And why this faceted surface appear on the fracture surface of a brittle material? This is because we know that in a polycrystal, the grain has different orientations. So if we talk about BCC metal and that to iron, we know that it has the cleavage plane 001. So if this is the 001 plane, the crack first propagate on this plane, then in the neighboring grain, because we know the neighboring grain has different crystallographic orientation, the crack changes the direction and start moving again on 001 plane. Because the crack has to move only on 001 plane, it changes its direction. If you want to understand, you can take a rectangular box. For example, I take a duster and I say that this is the front face, and I say that the crack is propagating on the 001 plane. This is the 001 plane. Now I rotate the duster in the next case and I say because the crack wants to move only on 001 plane, now this is my front face, please consider this, and because I know that the crack wants to move only on 001 plane, it changes its direction in this manner and start again moving on the 001 plane. So the first it is moving in this direction and then it's in this. You can assume it in 3D, and if the crack is moving in this direction and then the next time it will move in this direction. So this whole plane get fractured and this whole plane get fractured. You can assume it in 3D. So when this whole plane get fractured, this will appear flat. This will also appear flat, and that's the reason they appear as the faceted surface. And because these appear flat and they have the capability to reflect light very well, in that case they appear shiny. And if the cracks are present at the grain boundaries as well, then in that case this become intergranular, otherwise it's a transgranular because a fracture has occurred through the grains. Now if there is any irregularity on the fracture surface, then in that case we can observe river pattern. So river pattern forms from the multiple tributaries. So sometimes what happen, the crack start moving on multiple 001 plane or any plane, multiple parallel planes, and when they merge together they give rise to a river. So these are the tributaries which merge to produce a river. So the crack is moving in this direction. Now we will move to the ductile fracture. Here when we take a ductile material and start elongating it, it first reaches its elastic limit and then ultimate tensile strength point, and finally it fractures. So once it reaches the ultimate tensile strength point, in that case at this point necking start occurring because the length is elongating, and because the length is elongating, during plastic deformation the volume of the material remain conserved, the area start decreasing, the plastic deformation is concentrated at this particular part and the area start decreasing, and because the area start decreasing, this particular part wants to go inside but the surrounding part doesn't want it to come inside, so there'll be a stress state that is present here as well. So there is triaxial stress state that is generated in this center part, and because the stresses are equal in all the direction, then in that case it will be called hydrostatic stresses, and because of the hydrostatic tension, the voids are formed, and if there is hydrostatic compression, the voids get closed. So these voids are formed, and these voids then coalesce together to form a crack, and then the crack start propagating. It first undergo a flat fracture and finally undergo shear at the periphery. So this particular part which has shear lips, this is the flat part, this is the shear lips. So the part which has shear lip with it, that is called cup, while the other part is called cone. If you want to see the images, this part will be called as cone and this part will be called as cup. If it's a extremely pure metal single crystal, then there will be no imperfection in the material. So in that case, the cup and cone fracture surface will not form. The rupture occurs to a point. Necking occurs to a point. So because of the presence of the imperfection in the material, the fracture surface is made up of dimples. So this is the fibrous surface which is made up of dimples. If you enlarge on it, this is the dimple which we can observe, and we can see that dimples are present at the bottom of the second phase particle. The second phase particle is the source of void formation. So once the void forms, it enlarges by coalescing with the surrounding voids and then finally forms at the bottom of the second phase particle. Dimples are basically the conical features on the fracture surface. Like on our face, we can observe dimples on somebody's face. We can observe dimples that are the conical features. The same kind of features are present on the fracture surface when there are second phase particles present. So if you want to see the center part, then equiaxed dimples form, while at the periphery, because of the shear fracture, inclined dimples form. This is all about fractography. Hope you like the video. See you in next video. Thank you.